So first, I am going to give you kind of some mind or brain teaser. So f of x is equal to x squared plus 3x minus 1. F of heart is equal to heart squared plus 3 heart minus 1. Can you tell what I did? You don't have to write down any of this.
No, x is heart is the same as x. Yeah,
you just
Okay, so x is the same as heart. What's that? I just replaced it. Okay, let's look at another one. You don't have to write down any of this. Okay, what did I just do? Replaced it with smiley face. Okay, all right, let's try another one. It's gonna be a star.
Not now, you can change it.
Now that you told me. Okay, what did I do?
You made it A.
I made X an A. Yep. Okay, next one. Time. Okay, what did I do? I plug it in. What does that mean? Okay, I replaced x with 3 and I put it in. Okay, all right. So next one. Can you figure out what to do? Absolute value?
10 minus 2 absolute value plus 8.
Do you know what that number is?
16.
16. Okay. Last one. Can you tell what to do? This one's a little bit hard.
X squared plus h plus x plus h plus 1.
X plus h squared.
Okay, parentheses, very good.
Squared.
Plus x plus h plus 1.
Okay, very good. Okay, next. This is a puzzle you and your partner have to solve together. So look at that graph and look at that notation. Can you and your partner figure out what is going on? Okay, write down what you think down.
Function.
Just like what's going on, how does the graph relate to those notations? And then write your answer below. Okay, Jeff and Matt, what did you guys wrote down?
We don't know.
You don't know.
Yeah,
You didn't make any guesses?
Other than that, it looks like a mountain.
Okay, Isaiah and Eden.
Each of those things, like -2, 4, -1, 3.5, are point.
Okay, can you be more specific? What's going on?
The negative 2 is the x, and the equal to that's the 4 is the y.
Okay, so Aiden and Isaiah found out that that part is x and then the other part is y. Okay. Let's see. How about Daniel and Kendrick? What'd you guys find out?
We just found out x and y.
Okay, so kind of like what he said?
Yeah.
Okay, that is correct. So if you see this one says -2 and 4, so -2, 4, it's actually this point. So
Oh, I knew that. I didn't know we were trying to. Okay.
right, we're trying to say like how are they related to each other, the graph and the notation. So yes, inside the parentheses is x and then the equal to is going to be the y. And that is the case all the time. So basically f of x is equal to y. So f of x is actually another way of saying y. So the function of some x value is equal to y. All right, so let's go ahead and actually evaluate. So if you have a function that is -2x plus 5, f of -3, what am I going to do with that -3?
Put it in for x.
Put it in for x. Okay, so this is going to be -2 times -3 plus 5. So x is now -3. And then we're not just plugging it in for fun. We are actually going to evaluate. So we're going to actually solve this. So this is going to be 11. Good? Okay. please just be careful with your parentheses. Every time you substitute in a number, you gotta put in that parentheses so you don't forget. So go ahead and do your other ones, B, C, D. Let's check your answers. So let's start with Hillard. B, what did you get?
0.
No, not 0.
Oh, 5.
Huh? Yes. Okay, Jackson, C. Did you get a number? 18 over 4. Can you reduce it? Yeah, so what you want to do is just divide by 2 over 2. So that's 9 over 2. All right. Lynn, you have the hard one. Okay. Uh-huh. And then? Oh, okay, you say plus 5. Yeah. Okay, so that's how you do that. Okay, now let's go ahead and go to our next page. So what's happening is that we really just have a function machine. So you guys have been to like amusement parks where you put in, like now it costs like 2 quarters. No, maybe more. 2 quarters and a penny? Is it still 2 quarters?
Like for what?
For what?
For like, you know those machines? Yeah, the penny, yeah.
It's like 50 cents.
Is it still 50 cents?
Yeah.
Oh, 51.
Sometimes
Money
it's
paid more
4
than.
quarters, actually.
Yeah, right? Okay, so basically you put in some money and especially that 1 penny, that really shiny one that you want to get pressed. So you put in that thing, the machine, and then you crank it. Or I don't know if it's automatic now. We used to be, you still crank it yourself? Okay, so you crank it and then it creates some kind of design. So like it flattens it and then put some design on top and then it drops out a penny that is no longer a penny with some kind of design. So that machine is our function machine, kind of the same. So basically this is my f of x. And we drop something in. That's your penny that goes in. So in our case, we drop in x. And then what comes out on the other side is f of x, basically the changed x. Like we put something on x and now it's changed and then basically it comes out as y. And so that means what we put in, we call it input because we're putting something in. And then what comes out is the output. There are many different ways to represent your input and output. In particular, there are 4 ways. So for example, order pair. So we can represent our functions using order pair. Order pair means x and y. So for example, -3, 4, 3, -1, 4, -1, and 4, 3. They're all ordered pairs. So they represent like if I put -3 in, I get 4 out. I put 3 in, I get -1 out. And so on. Okay, that's one way to represent it. The other way to represent it is called the mapping diagram. So mapping diagram looks like this. On the left, we have our x's, and then on the right, we have our y's. And let's say we want to take those 4 ordered pairs and we want to map them. So what we're going to do is we're going to take all the x's and then put it on the left, all the y's and put it on the right. But the way we do that is, yeah, we're going to have to draw some lines to do some matching. But first, we're going to have to look at all our x's and then we have to put them in ascending order from smallest to largest. Okay, in this one, we have -3, 3. 4 comes up twice. Since it's repeating, we just write it once. So -3, 3, 4. We don't write 4 twice because it's the same number. And then we write all our y values. That's in ascending order, so from the smallest to the biggest. So it's going to be -1, which happened twice. Okay, so we only write it once. So -1, 3, 4. And then what we're going to do is just like a matching game. So -3 goes with 4, so we're going to do -3 match it to 4. So we're saying that they go together because they are one ordered pair. And then we do the same with 3, -1, 4, -1, and 4, 3. Okay, so it's just matching. So that's called a mapping diagram. You map it to another one. So map from x to y. Tables, very easy. You just rewrite the whole order pair series into a table. So -3 goes with 4, 3 goes with -1, 4 goes with -1, and 4 goes with 3. And then graphing, I'm sure you know how to graph. So go ahead and graph those 4 order pairs. Good? Easy? Just kind of review. Next 2 words are probably one of the most important things that we'll learn this year is domain and range. Do you remember what domain means? So long ago, probably. Yes, x values. So what are the possible x values of the function? And since x values are what we put into our function machine, we also call them the input. Okay, what about range?
Y.
Good, y values. And y values, we call it the output. Okay, now we have some function checks. So not everything that exists in life is a function. So we have this idea of what's a function and what's not a function. There are a few things you can do to check. First, every input can only have one output. So every x can only have one y coming out. But y's can have 2 x's. That's okay. Just x can only have one y. So let's look at it, and we are going to decide whether it's a function or not. So number 1, you have your domain, which is the x value or the input on the left, and then it's mapping to the range. So let's have you and your partner discuss, is this a function? So yes or no, and why? So if it's a function, x can only have one y value. Okay, so talk to your partner, is this a function? All right, let's vote. How many people say yes, it is a function? Raise your hand. Okay. How many people say no, it's not a function? Ooh, people are not sure. These people are not voting. All right, let's give you 30 more seconds to talk about it. To be a function, every x can only have one y. Try again. How many people think it is a function? Raise your hand. How many people say it's not a function? Ooh, you guys are good. It is a function. What about this really strange thing that's happening? There are 2 arrows going to the same number in range. Is that okay?
Yes.
Why is that okay?
Because.
Sorry, he always raises his hand and everyone else just says something. Okay, Josiah.
Because 2 inputs can have the same output.
Correct. 2 inputs can have the same output. That's okay. Just one input cannot have 2 output. Okay, so that's not okay. All right, so let's have you look at this one again with your partner. Is this a function or not, and why? All right, number 2, let's vote. How many people think yes, it is a function? Raise your hand. How many people say no, it's not a function? Okay, thank you. It is not a function. Why is this not a function? Sorry, Lauren.
4 has 2 outputs.
4 has 2 outputs. That's correct.
So y can have 2 inputs, but an x can have 2. Exactly.
Correct.
Okay.
Okay, next. We come to the second way, which is what most people remember. We got to pass the something something test. Yeah.
Vertical line test.
Yes, vertical line test. Vertical line test.
Never done
I feel like I've seen this. Yeah, I don't think
So vertical line test is the ultimate way of checking whether something is a function, and everybody kind of remembers that. So what you do is you draw a straight line, and then you see if it passes through more than one point. If it does, it's not a function. For example, let's look at this graph. You're going to draw a straight line down. Does it pass through more than one point? No, only 1 point, right? Okay, however, if I cross here, how many points do I cross? 2. Ooh, not just 2, right? 1, 2, 3. Let's say it's a really nice, like, backwards S. So it's going to pass through 3 points. So is this a function or not?
No.
No. What about, but you know, on the left-hand side, I only pass through 1 point.
Doesn't matter.
Doesn't matter. As soon as it passes through more than 1, the whole thing fails. It doesn't matter if you were okay here. It doesn't matter if you're okay here. As soon as it passes through more than 1 point, in any given place, it is a fail. So this is not a function.
This function will be failed. You did not function correctly.
All right, how about B? Yes. So no matter where I draw a line, it's always going to only pass through 1 point. So that is, yes, a function. What about this one? Yes. Okay, this, no matter how I draw it, I also only go through 1 point. Okay, we are going to now take our function and actually do a word problem. So these word problems are easy to solve, but the whole idea is can you kind of, instead of just solving it, can you write a function to represent it? So let's look at this question. Tickets to a concert are available online for $35 plus a handling fee of $250. All right, this part is not very clear. Let's just say that it's $250 total for everything you order. So it's not like every ticket is $250 more. It's just like one single sale, and at the end they add a $250. So they're very nice. So if you buy 10 tickets, it's still just one $250. If you buy 1 ticket, it's still just one $250 handling fee. Okay, so one-time fee. Okay, so each ticket is gonna cost $35, and then at the end you pay a $2.50 handling fee. The total cost is a function of the number of ticket bought. The total cost is a function of the number of ticket bought. So function, remember we're talking about function today, so the number of ticket is going to be my x, and then what comes out, total cost is going to be my y. So total cost is, remember is means equal, a function of the number of tickets. A function of the number of tickets. What function rule models the cost of the concert ticket? That is part A. Evaluate the cost or the function for a 4 ticket. That is B. Okay, so first we need to write a function. So f of x. That tells us how to figure out the cost of the ticket. Okay, so each ticket costs $35. At the very end, you pay a $2.50 handling fee. So how do you write an equation, Lauren?
35x plus 250.
Okay, $35 per ticket, so 35x plus $2.50 at the very end. So that would be our function. So remember, if you were just, like last chapter, we were just writing 35x plus 250. All you do now is you add a f of x in front. Okay, second question. Evaluate the function for 4 ticket. Evaluate the function. So we want to figure out what it is for 4 tickets. So you put 4 into x. And that's going to be 35 times 4 plus 250. And what is that? Huh? Yes. Good. All right, let's have you guys practice. All right, first you have a function is 1.19x. And you're evaluating for 15 bottles, so that's going to be 17.85.